imagine for a moment, drifting far above the slow-turning wheel of our galaxy, looking down at a spiral of soft light that holds 100 billion stars. Before we go any further, if you want a brand new space topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. From up here, the universe feels vast and patient, an ocean of slow fire and quiet dust, with our small sun lost somewhere in one of the outer arms. This is where we begin tonight, at the soft edge where memory begins. Picture the cosmos stretched out in every direction, older than any thought, wider than any word. Galaxies hang like distant lanterns. Some glow blue and hot, some burn amber with the long warmth of ancient suns. Between them, deep voids open in slow, calm darkness. And tucked somewhere inside this great expanse, there is you, resting, breathing softly, remembering things. A face, a room, a song, a yesterday. Your memories feel solid. They feel like proof that the world has been here all along, that you have been moving through it, that the stars above were shining long before you opened your eyes. But tonight, gently, we are going to wonder about that. We are going to sit with a strange and quiet question that some thoughtful physicists have taken seriously for more than a century. The question is this: what if your memories never really happened? What if the universe around you is far younger than it seems? What if you, this very moment of thinking and feeling, popped into being only an instant ago, complete with a head full of false recollections, in the middle of a much older and emptier cosmos? This idea has a soft, almost dreamlike name. It is called the Boltzmann brain. It comes from the work of a thinker who studied heat and motion in tiny particles, and who noticed something puzzling about how order and disorder shift across long stretches of time. We will return to him gently in later chapters. For now, only the picture matters. A single thinking mind, forming briefly out of the random shuffling of atoms in a vast, cold sea. A mind that believes in a world. A mind that may be wrong. Drift back out with me, away from your warm room, away from your planet. Imagine the universe many trillions of years from now, long after the last bright stars have burned down to embers. Space is colder than any winter you can picture. The galaxies have drifted apart until each one is alone, surrounded by an endless dark. In that quiet, particles still jitter. They always do. And given enough time, given truly unimaginable time, even rare arrangements become possible. A swirl of dust here, a clump of warmth there, and perhaps, once in a great while, a momentary thinking thing, complete with the soft conviction that it has lived a life. This is the puzzle, gentle and serious at once. If such momentary minds can form, even rarely, then across the great long span of cosmic time, there could be far more of them than there are ordinary minds like ours, born on planets, growing up slowly under real skies. And if that is true, then statistically, any mind that finds itself thinking, including yours tonight, might be more likely to be one of the fleeting ones. Some researchers find this argument troubling. Others find it useful, a kind of mirror held up to our theories of the universe, showing where those theories may not quite fit together. There are several competing views, and we will visit them slowly across the coming hours. One view says the idea reveals a real problem in how we understand time and probability. Another view says the idea quietly defeats itself because a mind that cannot trust its own memories cannot trust its own reasoning either. The question remains open. Honest minds disagree. For now, simply rest in the scale of it. A universe so wide and so old that even the meaning of remembering becomes uncertain at its furthest edges. A sky so deep that the question of who is doing the looking begins to shimmer. You do not need to solve anything tonight. You do not need to decide whether your memories are real. You only need to let the question float there, soft as starlight, while your breathing slows and the room around you fades. We are going to spend the next few hours drifting through this gentle mystery together. There is no urgency. There is only the wondering and the long, slow turning of the cosmos and the quiet edge where memory begins. Let us begin with the simplest version of the puzzle, the one you could whisper to a friend in the dark and have them understand right away. The idea is called the Boltzmann brain. The name comes from a physicist who lived in the late 1800s, a man who spent his life thinking about heat, motion, and the slow drift of things towards stillness. He never used the phrase himself, but his work opened a door that other thinkers walked through much later, with a strange and quiet question in their hands. The question goes like this: what if a mind could appear all at once, out of nothing in particular, not born, not grown, not raised, just assembled for a single moment by the random shuffling of tiny particles in the deep cold of space? A brain that thinks it has a life, a brain that remembers a childhood, a name, a face by the window. But none of those things ever happened. The memories arrived with the brain, fully formed, like a book printed with a story already inside it. The strange part is not that such a thing could exist. The strange part is how it could feel. From the inside, a mind like this would feel exactly like you feel right now. It would notice the soft weight of a blanket. It would hear the hush of the room. It would have a sense of yesterday, of last week, of the long, slow shape of its own life. And every one of those impressions would be a kind of dream, painted onto the moment of its making. To picture the setting, imagine a universe far older than ours. Picture a sky drained of stars, the last glowing embers long since cooled. Picture a vast, dim emptiness, colder than anything you have ever touched, stretching out in every direction without end. In that emptiness, particles still drift. They bump and scatter, very rarely, across stretches of time so long they make our whole history seem like a single breath. And once in a great while, the theory suggests, those particles might happen to arrange themselves into something startling. A small clump of matter, a delicate web of connections, a thinking thing. The chance of this is almost unimaginably small. A single brain formed by accident from cold dust would be one of the rarest events the universe could produce. But the universe, in some models, has all the time it needs. If you wait long enough, even the rarest things begin to seem ordinary. And if you wait longer still, the rare things may outnumber the common ones. That is where the puzzle begins to bite. Our universe, as we understand it, also produces minds the slow way. Through stars and planets, through chemistry and biology, through long chains of cause and effect that stretch back almost 14 billion years. Those minds are wrapped in real bodies, sitting in real rooms, on a real world that spins around a real sun. We feel certain we are this kind of mind, but the cold theory whispers something unsettling. If the universe lasts long enough, and if the random fluctuations keep happening, then minds from nothing might eventually be more common than minds from history. And if that is true, a thinking thing has to ask, very gently, which kind it is. No one knows the answer. Some thinkers find the idea fascinating, but unlikely, a curiosity at the edge of physics. Others take it seriously enough to argue that any theory of the universe which predicts too many of these accidental minds must be wrong. Somehow, in a way we have not yet found, a few researchers wonder whether the question itself is broken, whether the math we use to compare these possibilities does not really work across such impossible stretches of time. The debate is quiet, patient, and unfinished. For tonight, the only thing you need to hold is the shape of the question. A mind without a past would feel exactly like a mind with one. The memory of breakfast, the sound of a name, the small ache of an old regret, these would all arrive together in the same instant, with no way to tell the difference between something remembered and something simply given. The light in the room would feel familiar. The body would feel familiar. The world outside the window would feel like it had always been there. And so the puzzle settles in beside you, soft and slow. Not a fear, not a warning, just a strange, quiet wondering about what memory really is, and where it really lives, and whether the universe could ever play a trick so gentle that no one inside it would notice. The idea that our memories might not refer to anything real did not arrive in a single flash. It drifted into physics slowly, almost shyly, through a back door no one had been watching. To understand how this strange thought was born, we have to travel back to the late 1800s, into the quiet study of heat, motion, and the way order tends to fall apart. A physicist named Ludwig Boltzmann was trying to explain why time seems to flow in only one direction. Why hot tea cools? Why broken cups never gather themselves back into a hand? His answer involved a soft, steady idea called entropy. Entropy is, in plain words, the measure of how spread out and disorganized the bits of a system have become. A neat stack of cards has low entropy. A shuffled stack has more. A pile of cards scattered across the floor has more still. Boltzmann showed, with patient mathematics, that systems tend to drift toward higher entropy because there are simply more ways to be messy than to be tidy. But this answer left a soft, troubling thread hanging. If the universe really tends toward disorder, why is it so orderly now? Why are there stars at all, gathered into spirals, when a smooth, warm haze would be far more likely? Boltzmann offered a gentle guess. Perhaps the whole cosmos is, on the largest scale, already a warm, even haze. Perhaps we live inside a rare ripple, a quiet pocket where the haze briefly dipped into order. Given enough time, and time in this picture is almost endless, such ripples must happen now and then. That guess is where the strange seed was planted. Because if random ripples in a vast warm sea can produce a galaxy, they can also, in principle, produce smaller things. A planet, a forest, a single thinking mind, complete with the impression of a long life behind it. And here is the soft, unsettling part. A small ripple is far, far more likely than a large one. A whole, orderly cosmos is an astonishing rarity. A single brain fluctuating into being for a moment is staggeringly more common in the long arithmetic of forever. Boltzmann himself did not push this thought into its full shape. He died before the idea matured. The phrase we use now, Boltzmann brain, came much later, as physicists in the 20th and 21st centuries returned to his old puzzle with fresh tools. They asked, with quiet seriousness, what his picture really implied. If the universe lasts long enough, and if random fluctuations can shape matter into thinking forms, then most observers who ever exist should be lonely flickers, not long-lived people on long-lived worlds. Some thinkers found this conclusion so strange that they took it as a warning. The cosmologist Sean Carroll has argued that any theory which predicts most minds are fleeting fluctuations is, in a soft sense, defeating itself. If our memories are random, then then the science we used to reach the conclusion is also random, and we cannot trust it. He calls this cognitive instability, a theory that undermines its own reasoning. He suggests should be set gently aside. Others are not so sure. They argue that the math is the math, and that we must follow it where it leads, even into places that feel uncomfortable. Recent reanalyses, including work associated with researchers at the Santa Fe Institute, have tried to sharpen the question. They ask whether the assumptions about infinite time, about the behavior of empty space, about how fluctuations really work, are firm enough to support the conclusion. The answers are not yet settled. There are competing pictures of how the universe began and how it will end, and each one shifts the puzzle. In some models of cosmic inflation, the idea that the early universe stretched at tremendous speed, fluctuation brains may be rare or perhaps impossible. In other models, they may dominate the count of all observers. The choice between these pictures depends on details we do not yet know, including what dark energy truly is, and whether space will keep expanding gently forever. So the origin of this idea is not a single discovery, but a slow gathering of doubts. It grew from a man trying to explain why a cup of tea cools, and it grew into a question about whether any of us have ever really lived a single day. The theory of forgetting, in its quiet way, was born from the theory of heat, and it has not yet found its rest. Many careful minds still wonder which assumptions to keep and which to release, and that wondering is itself part of what tonight invites you to hold lightly as you drift. Think for a moment of the elements that make a thinking thing. The carbon in every cell, the oxygen carried in every breath, the iron threaded through the blood, the calcium woven into bone. Each of these atoms came from somewhere. Each was forged in the slow furnaces of stars, scattered across space when those stars came undone, and gathered again into the soft, warm shape of a person who can wonder about the sky. This is the ordinary story we tell ourselves about where we come from. Tonight, gently, we hold that story up to the light and notice that it depends on memory. A Boltzmann brain, if such a thing exists, would also be made of atoms, carbon, oxygen, iron, the same familiar list. But these atoms would not have a history the brain could trust. They would seem to come from stars. They would carry the appearance of a long cosmic story. Yet that story might be only an impression, lit up inside a thinking thing that flickered into being from the random shuffle of a cold and distant future. The materials are real. The memory of where they came from might not be. This is the strange tension at the heart of the thought experiment. Everything you can name only because the universe seems to hold together long enough to be studied. The iron in Earth's core was, as best we can tell, forged in the cores of dying stars, in the crushing heat of supernovae, and in the slow merging of dense stellar remnants. The gold in a wedding ring, the silver in old coins, the rare metals in the device that may be playing this voice. All of them, we think, were cooked in violent stellar deaths long before our sun was born. The water in the oceans may have arrived in part on icy comets and dust grains, drifting in from the outer dark when the earth was young. Each of these claims rests on observation, on chemistry, on patient measurement across many lifetimes of scientists. Each requires a universe that has been here a long time, behaving in steady ways. A Boltzmann brain would have no access to that long, steady history. It would only have the feeling of access. It might glance, in its brief moment, at the inside of its own thought and find a memory of a textbook page describing how stars build heavy elements through fusion. The memory would feel solid. The page itself would be nowhere. Some thinkers find this troubling because it suggests that even our most careful reasoning about cosmic chemistry could be a fluke pattern in a fluctuation. Others answer that this is exactly why the idea is mostly used as a warning, not a belief. If a theory of the universe predicts that most observers are random brief brains rather than long-lived beings on planets, that theory is probably broken. The argument runs in the opposite direction from what it first seems. The point is not that you are likely a flicker. The point is that any cosmology which makes you likely a flicker is a cosmology to be suspicious of. Still, the materials remain the same in both pictures. In one, the iron in your blood is a small inheritance from a star that lived and died before our sun ever shone. In the other, the iron is only an arrangement, here for an instant, with no real ancestor. The atoms cannot tell you which story is true. They simply sit in their patterns, doing what atoms do. Notice how much of what we call knowledge is really a chain of trust between materials and memory. We trust that the rocks in a meteorite came from the early solar system because we trust the methods that dated them, and we trust the methods because we trust the long history of careful work that built those methods. Pull on any thread of that chain, and you find another thread behind it, and another, all the way down to the simple act of remembering what was learned yesterday. Without memory, the chain has no links. The rocks are just rocks. The stars are just bright points. The story of where the iron came from goes quiet. Maybe the universe really is old and rich and full of stellar history. And we really are the slow children of dying stars. Most working scientists treat this as the natural picture because it makes the world hang together. The other picture, the lonely flicker, stays at the edge of the conversation as a question that will not quite go away. The building blocks are the same in both. Only the long story behind them changes, depending on whether memory can be trusted at all. The forces that shape a mind without a past would not be the familiar ones. They would not be gravity pressing a star into a sphere, or pressure squeezing the core of a planet until it glows. They would be something stranger. They would be the forces that shape moments themselves. To wonder about the Boltzmann brain idea is to wonder about how time, heat, and chance might sculpt a thinking thing into being, just once, for the briefest flicker. Consider how heat moves through the universe. Heat spreads. A warm cup of tea cools in a cold room. The room never warms a cold cup of tea on its own. This one-way drift is what physicists call the second law of thermodynamics. It is the slow march from order toward disorder, from gathered energy toward scattered energy. The universe, as far as we can tell, is doing this on the grandest scale. Stars burn through their fuel. Galaxies drift apart. The cosmos cools. Yet, within this long cooling, tiny reversals are allowed, not forbidden, only rare. A molecule of air might, by pure chance, swerve back toward warmth. A patch of gas might, for a heartbeat, gather itself into a denser knot. These are called thermal fluctuations. They are the small, unlikely twitches of a universe that, on average, is winding down. Most fluctuations are so small they vanish at once, but given enough time, even very large fluctuations become possible. Given enough time, anything that can happen eventually does. That is the strange force at work in this thought experiment. Not gravity, not pressure, just deep time and chance. Given a universe old enough, cold enough, and patient enough, the random jostling of particles might, once in a vast while, arrange itself into something improbable. A swirl, a structure, a pattern, and in principle, even a thinking mind, fully formed, complete with memories that never happened. This is why the question feels so unsettling and so beautiful at once. The force that might shape a Boltzmann brain is the same gentle force that lets a warm room slowly cool. It is the quiet shuffle of particles, repeated for spans of time so long that our words break against them. We are not talking about millions of years or billions. We are talking about numbers with more zeros than atoms in your body. In such depths of time, the rare becomes routine. Some physicists, like Sean Carroll, have argued that this idea pushes back against itself. If random fluctuations could produce a single brain, they would do so far more often than they would produce a whole universe. A whole universe is a much larger, much more orderly arrangement. It takes far more luck to assemble. So a thinking mind, floating alone in the cold dark, would be the cheaper outcome, the more common one. By that logic, most observers in the far future of the cosmos might be lonely brains, not beings inside real worlds. Other thinkers push the other way. They point out that we have no good way to count these possibilities. The mathematics of comparing infinities, of weighing one kind of observer against another, is called the measure problem. And the measure problem is not solved. Some researchers wonder if the whole framework breaks down before it ever reaches a clear answer. The forces at work might be different than we imagine. The cooling of the universe might not go on forever. New physics, still unknown, might end the long drift before any such fluctuation ever has the chance. So the forces shaping this mystery are deep time, gentle disorder, and the soft pull of probability. They act on no particular scale. They favor no particular place. They simply wait. They are the slowest sculptors imaginable, working not in millennia, but in eternities. And the question they pose is whether you, right now, listening to this voice, are a product of billions of years of star formation and planet building, or a fleeting knot of warmth in a cold and ancient sea. There is no way from inside the moment to tell. A mind built by chance would feel exactly like a mind built by history. The memories would be the same. The voice would be the same. The quiet room would be the same. That is the strangeness of these forces. They sculpt invisibly. They leave no mark you can find by looking. For tonight, let the thought rest gently. The forces at play are slow, patient, and unhurried. They do not demand an answer. They only suggest, in the softest possible way, that the line between a real past and a vivid impression of one is thinner than it seems. We will keep wondering. The cosmos, for now, keeps cooling. Step outside on a clear night and look up. The sky feels familiar. There is the curve of the Big Dipper, the slow drift of a planet near the horizon, the band of soft light we call the Milky Way. You know these shapes because you have seen them before, and because someone long ago traced them and gave them names that traveled down to you. The sky is a kind of memory. It only works because you remember it. Now imagine that memory is gone. Not the stars. The stars are still there. Only the recognition is missing. Each point of light is brand new. There is no pattern, no constellation, no sense that the sky last night looked anything like the sky tonight. It is simply scattered brightness on a dark field. To grasp what that means, it helps to feel the real scale of what is being forgotten. Think of the sun as a single grain of sand held between your fingers. On that scale, the nearest star outside our solar system would be another grain of sand, roughly 40 miles away. The space between them is empty, dark, and almost perfectly still. Now zoom out. Our galaxy, the Milky Way, holds somewhere between 100 billion and 400 billion stars. If each star were a grain of sand, you could fill a beach, a long beach, the kind that stretches past the horizon in both directions, with the sand piling up taller than a person. And the Milky Way is one galaxy. The observable universe holds maybe 2 trillion of them. If each galaxy were a single grain of sand, you would need many beaches. You would need every beach on Earth, and then some. The numbers stop feeling like numbers. They become a kind of soft pressure behind the eyes. Hold that scale in mind, and now think about a single human brain. About 3 pounds of soft tissue, roughly the size of 2 clenched fists pressed together. Inside it, something has kept track of which patterns of light belong together. Orion, the Pleiades, the Southern Cross. A small, warm, wet object on one small planet has been quietly mapping a sky that contains 2 trillion galaxies. The map is incomplete, of course. We see only the brightest pieces. But the mapping itself, the recognizing, is the strange part. The thought experiment whispered through this episode asks whether that mapping might be an accident, whether a brain like yours could appear briefly in the long thermal hush of a far future cosmos, not because a real sky shaped it, but because random motion happened to assemble it that way. To feel why this idea bothers physicists, you have to feel the time scales involved. Our universe is around 13.8 billion years old. That is a long time by any human measure. But the kind of deep future where random thermal fluctuations might assemble a thinking brain is not measured in billions of years. It is measured in numbers so large they cannot be written out. A 1 followed by more zeros than there are atoms in your body. More zeros than there are stars in the visible universe. In that quiet, almost endless future, anything that can happen by chance eventually does, including, some have argued, the brief flicker of a mind that thinks it remembers a sky. If that is what you are, then the constellations you learned as a child were never really learned. They were placed into you, fully formed by random motion. The sky you remember would not be a record of anything. It would be a pattern that arrived already complete, like a photograph printed by accident. Most researchers do not believe this is actually happening to you right now. The competing view is that real, ordered universes like ours produce far more observers in the normal way. By growing up under real skies, looking up at real stars, remembering them over years. On that view, you are almost certainly the ordinary kind of mind, and the night sky you know is the night sky that shaped you. But the question of why ordinary observers should outnumber the fluctuated kind, when deep time is so unimaginably long, is not fully settled. Different models of the universe give different answers, and some of those answers are uncomfortable. For tonight, it is enough to sit with the strangeness. The sky overhead is enormous beyond grasping. The brain beneath your skull is small enough to hold in 2 hands, and somewhere between those 2 scales, something has been quietly recognizing patterns. Whether that recognition rests on a real past or only on the appearance of one remains an open question. The stars, for their part, simply shine. Picture for a moment that you could float above the surface of a single thought, not the thinker, just the thought itself, suspended in the dark like a small lit cloud. From this strange vantage point, the surface of a self would not look solid at all. It would shimmer. It would drift. It would have the soft, uncertain edges of warm breath on a cold window. This is the surface we want to wander tonight. The thin outer layer of what it feels like to be someone. The skin of the self, if such a thing has a skin. The Boltzmann brain idea asks us to imagine a mind that flickers into being in the deep cold of space, complete with memories that never happened. If you could hover above that mind, what would you see? You might see something like a faint glowing orb, no larger than a thought, drifting through an endless black. Its surface would not be smooth. It would ripple, the way the skin of a soap bubble ripples in slow light. Inside the ripples, you would see flashes. A childhood kitchen, a face that was never real, a summer afternoon that was never lived. Each flash would feel solid from the inside, and from the outside, it would look as thin as mist. The strange loop begins right here. The mind on that surface believes it has a past. It believes it has walked through rooms, opened doors, kissed people, watched rain. But the mind is younger than a heartbeat. It has no real history. Its memories are part of its surface, painted on like color on a shell. From the outside, the painting and the shell are the same thing. Some thinkers, including the physicist Sean Carroll, have pointed to a quiet problem hidden in this picture. If you truly were such a brain, your thoughts about physics, about probability, about anything at all, would not be trustworthy. Your reasoning itself would be a brief sparkle in the noise. This is sometimes called cognitive instability. It is one of the strongest reasons many researchers think the Boltzmann brain scenario, taken literally, undermines itself. A theory that says you cannot trust your own thoughts cannot really be argued for using those thoughts. Other researchers see the matter differently. They treat the paradox as a useful warning sign about our models of the cosmos, not as a real description of who we are. In their view, if a theory of the universe predicts that most observers are lonely flickers in the dark, then the theory has a flaw somewhere. The flaw might be in how we count observers. It might be in how we picture inflation, the early stretching of space. The question of which view is correct remains open. Float a little closer to the surface of that imagined mind. Notice how the boundary between inside and outside seems to fold. The thought thinks about itself. It wonders whether it is real. The wondering is also part of the surface. There is no deeper layer to retreat into, no quiet attic where the true self waits. The wondering is the self, and the self is the wondering. This is the loop. Our own minds may have the same shape, even if we are not Boltzmann brains. When you try to find the one who is thinking, you find only more thinking. When you try to catch the watcher, you find only more watching. The surface keeps curling back on itself. Some philosophers have called this a strange loop, a structure that points at itself and never quite touches bottom. If the cosmos really did produce such flickering minds in its far future, their surfaces might look almost like ours from the inside. Warm, familiar, full of stories. The difference would be invisible from within. That is part of what makes the question so quietly unsettling and also so beautiful to sit with. We cannot test from inside a mind whether the mind has a past. can only notice that it feels like it does. So we keep both possibilities gently in hand. One possibility is that we are exactly what we seem, long-lived creatures on a small blue world, with real childhoods behind us. Another possibility, taken seriously by some, treated as a paradox by others, is that minds like ours could in principle appear without any history at all. The honest answer is that we do not yet know how to rule one of these out with certainty. For now, let the surface shimmer. Let the loop turn softly. The self that listens to these words may have walked a long road to get here, or it may be the briefest of sparks. Either way, it is here, wondering, which is a kind of small miracle on any account. Now we drift into the deeper layer of the question, the part that hides beneath the surface of the thought. On the surface, the Boltzmann brain idea sounds like a strange game. Below the surface, it touches something much heavier. It asks whether science itself could still work in a universe where most thinking minds appeared by chance. To understand this, picture how science is done. A researcher looks at the world. She gathers evidence. She remembers what she saw yesterday and compares it to what she sees today. She trusts her notes. She trusts her instruments. She trusts that the sky she observed last night will still be there tonight, holding the same stars in roughly the same places. Now imagine that her memories are not real records of past events. Imagine they are only the shape of a brain that flickered into being a moment ago. Her notes feel true. Her instruments feel solid. The stars feel familiar. But none of it points to a real outside world. It points only to the shape of a single fleeting mind. This is the heart of what some thinkers call cognitive instability. The physicist Sean Carroll has written about it with quiet care. The idea is simple, though it bends back on itself. If you believe you are likely to be a Boltzmann brain, then you cannot trust the very reasoning that led you to that belief. You cannot trust your memory of reading the argument. You cannot trust your sense that physics has laws. You cannot even trust the math you just used. A universe full of random brains is a universe where knowledge has no firm ground. So one quiet theory says the Boltzmann brain scenario refutes itself. If it were true, we could not know it. Since science depends on trusting our observations at least a little, any theory that predicts mostly random observers must be wrong somewhere. Not because the math is broken, but because the conclusion eats its own foundation. Other thinkers are not so sure. They wonder if the self-refutation is more like a warning sign than a clean answer. The argument tells us that something in our picture of the cosmos is off, but it does not say where. The error could hide in how we count possible observers. It could hide in our model of the early universe. It could hide in our guesses about what comes after the stars all fade. We may be staring at a clue without knowing which lock it opens. Beneath this lies an even stranger layer. A universe dominated by random brains would not just be hard to study. It would be impossible to study in any normal sense. Each brief mind would invent its own history. Each would believe in galaxies it never truly saw. No two random minds would share the same past because they would have no shared past to share. Science depends on many observers checking each other's work over time. Random brains cannot check anything. They appear, they think one fleeting thought, and they fade. This is why the deepest version of the paradox is not really about brains at all. It is about whether the cosmos can hold steady witnesses long enough for understanding to grow. Some researchers suspect this is the real lesson. The Boltzmann brain problem may be pointing at the conditions a universe needs to allow lasting knowledge. It may be telling us that any good theory of the cosmos must also explain why ordinary, embodied, long-lived observers like us are the common case, not the rare exception. One view says the answer lies in the early universe itself. The smooth, low entropy beginning we seem to have come from is what makes real history possible. Real memories form because the past was more orderly than the present. Without that gentle slope from order to disorder, there is no arrow of time for a mind to ride. A competing view says the answer lies in how we count. Maybe the universe is so vast or so strangely shaped that our usual way of asking which observers are more common simply does not work. The math of infinity grows tangled. Ratios become slippery. The question itself may be ill-posed, like asking which is the largest number. Both views leave the depths murky. We do not know if our memories rest on real ground or on a clever illusion that mimics ground. We do not know if the cosmos is built to favor steady witnesses or random ones. We only know that the deeper we look, the more the question of memory becomes a question about the structure of reality itself. And tonight, that question stays open, soft, and unresolved, like a light glimpsed far beneath dark water. Tonight we sit with the soft idea of cycles and what they might mean for a mind that cannot hold them. The universe, we know, moves in rhythms. Planets turn on their axes, painting day into night and night into day. Moons swing around their worlds in steady arcs. Worlds trace long ellipses around their stars. Stars themselves drift in slow orbits around the centers of galaxies, taking hundreds of millions of years to complete a single loop. These cycles only matter to a mind that can remember them. A season is a season because you have known the one before. A tomorrow is a tomorrow because there was a yesterday to compare it to. Without memory, each rotation of a world would be the only rotation. Each sunrise would be the first sunrise. The slow breath of the cosmos would still happen, but no one inside it would notice the breathing. This is part of what makes the Boltzmann brain question so quietly strange. A momentary mind born from a flicker of warm chaos in the deep future might carry the feeling of cycles within it. It might remember tides. It might remember the soft return of spring. It might remember the long arc of its own life, from childhood to this moment of thought. And yet, in that picture, none of those cycles would have truly happened. They would be patterns inside a single fleeting instant, like the shape of a wave that never had a sea. The physicist Ludwig Boltzmann, working over a century ago, wondered how order could appear in a universe drifting toward disorder. His equations suggested that, given enough time, even the rarest arrangements of matter could occur by chance. A jar of mixed gases could, in principle, briefly unmix itself. A handful of dust could, after unimaginable ages, gather into the shape of a thinking brain. The cycles of the cosmos were, in his view, statistical creatures. They rose and fell from the deep sea of probability. One theory takes this idea seriously and follows it to an uncomfortable place. If the universe lasts long enough, and if random fluctuations can produce minds, then the number of these brief, accidental minds might eventually outnumber the minds born from real stars and real planets and real evolutionary cycles. In that picture, a typical thinker would be one of the lonely fluctuations, not one of us at the start of a long cosmic story. The idea of tomorrow for such a mind would be a kind of illusion. There would be no tomorrow waiting on the other side of sleep. A competing view pushes back gently. Some researchers argue that the very laws which allow such fluctuations may also forbid them in practice. Inflation, the rapid early expansion of space, might keep producing fresh regions where ordinary cycles dominate, where real days follow real nights, where real seasons turn. In this view, the cosmos keeps making more reliable observers than thermal accidents. The arrow of time, the steady forward motion we feel, would be a true feature of our region, not a trick of statistics. Still, other thinkers point out that we have no settled way to count minds across an infinite future. This is sometimes called the measure problem, the puzzle of how to weigh different kinds of observers when the totals are endless. Without a clear method of counting, both sides of the argument hover in a kind of soft fog. The cycles of the cosmos may or may not vastly outweigh the flickers. The question stays open. What we can say is that, for now, the rhythms feel real. The earth turns. The moon waxes and wanes. The sun rises tomorrow with quiet reliability. Trees gather their rings. Galaxies wheel slowly through the dark. Whether these patterns are the bones of an ancient, ongoing universe, or the imagined memories inside a single warm spark, they remain the music we live by. A mind without a past has no use for cycles. A mind with a past lives inside them. The difference between those two states is, in some sense, what this whole question circles around. We may never fully prove which kind of mind we are. The thought experiment is not meant to frighten us into doubting the dawn. It is meant to remind us how much of our sense of time depends on the soft thread of remembering, stretching from one breath to the next. So as you rest, let the cycles carry you. the slow turning of the world beneath you, the steady rhythm of your breath, the quiet promise, real or imagined, of a morning that will come. Whatever the deep answer turns out to be, the rhythms tonight are gentle, and they are enough. Nothing in the cosmos exists alone. Every star drifts within a slow current of other stars. Every galaxy leans toward its neighbors through the soft pull of gravity. The Earth itself is a small island in a quiet stream, held in place by the sun, brushed by the gentle weather of solar wind, and watched over by a moon that has stayed close for billions of years. Even atoms are companions, sharing electrons, leaning on each other to form the soft fabric of the world. To be a thing in this universe is to be in conversation with what surrounds you. A memory works in much the same way. It is never just one thought sitting alone in the dark. A single memory leans on 1,000 others. The smell of rain leans on the memory of a window. The window leans on the memory of a room. The room leans on the memory of a person who once stood there. Pull on any thread, and a quiet network of echoes begins to hum. Without that network, a memory has no place to belong. The question this episode sits with asks, what happens if those echoes never form? If a mind appeared for only an instant, a brief flicker of warmth in a cold and ancient sea, it would have no neighbors, no earlier thoughts, no older selves, no friends waiting in the next room of the mind. It might hold the shape of a memory, but the memory would have nothing to lean on. It would be a single note with no song around it. Some thinkers have wondered whether a flicker mind like this could even count as thinking. A real thought, they suggest, needs neighbors. It needs the soft pressure of other thoughts before it and after it. A mind that exists for only a heartbeat may carry the appearance of a full inner life, but the inner life would have no companions to confirm it. The mind would be alone in a way that is hard to picture, because every mind we know has always had others nearby. Others push back gently. They wonder if neighbors are really required at all. Perhaps a single moment of awareness, complete in itself, is enough to count. The memories inside it might be false, in the sense that nothing they describe ever happened, yet the experience of having them might still be real. In that view, the flicker mind is not lonely. It simply does not know the difference between a memory with neighbors and a memory without them. Both feel the same from the inside. This is part of what makes the puzzle so quiet and strange. From within a mind, you cannot tell whether your memories have real neighbors out in the world. You cannot step outside yourself to check. The friends in your memory feel like friends. The childhood home feels like a home. The night sky feels like the same sky you saw last week. Each memory seems to lean on a real history, but the leaning happens inside the mind, not outside it. The neighbors might be only other thoughts, not other things. Astronomers face a softer version of this problem when they look across deep space. A distant galaxy seems to be surrounded by other galaxies, held in a web of gravity. To confirm that web, they must compare light from many directions, gathered over many years. The neighbors of a galaxy are known by patient measurement. A mind has no such method. It must trust its own internal map of who and what surrounds it. That trust is usually rewarded, but the Boltzmann brain idea asks, in its quiet way, what would happen if the trust were misplaced just once? If the universe is truly vast and truly old, then somewhere, in some far corner of time, a mind without neighbors might briefly form. It would feel surrounded. It would picture a family, a town, a sky full of familiar stars. None of it would be there. The echoes it relied on would never have formed in the world outside, only inside the brief warmth of its own pattern. Whether such a mind has ever existed or ever will remains an open question. Whether you are one right now is a question no measurement can answer. For tonight, the gentler thought is this: your memories may or may not have real neighbors out in the world, but within your mind, they lean on each other softly, the way stars lean on the galaxies that hold them. That leaning is its own kind of company. It is what a thinking thing feels like from the inside, whether the universe behind it is wide and ancient or only a flicker in the dark. Think of the extremes of memory, and you find a strange puzzle hiding inside the Boltzmann brain idea. Learning, in any familiar sense, seems to require holding. You see something, and you carry it forward. You touch something hot, and the lesson stays. Yet, a mind that exists for only a flicker, formed by chance from the warm noise of a quiet universe, would learn nothing at all. It would arrive already finished, complete with what felt like a lifetime of knowing, and then dissolve before any new knowing could form. This is the most extreme version of the puzzle. A fluctuation mind would be, in a sense, the briefest student the cosmos could produce. Its entire education would be illusion. Every skill it seemed to possess, every face it seemed to recognize, every word it seemed to have practiced as a child, all of it would be a pattern that simply happened to be there. The way a snowflake happens to have 6 points without ever having attended a class on geometry. The opposite extreme is the long, slow learning of a real universe. In that picture, knowledge builds across billions of years. Stars cook the elements that later become eyes. Eyes evolve over countless generations to read light. Brains slowly grow the folds and pathways that let a child connect a sound to a shape. Each step takes time, and each step leaves a trace. The traces are the holding. Without them, there is no learning, only the appearance of it. So the question becomes sharp. Which is the more common kind of mind in the long, deep future of the cosmos? A mind shaped by patient billions of years, or a mind shaped by sheer luck in an empty sky? Some thinkers have argued that, given enough time, the lucky minds win simply by repetition. A universe that lasts long enough and stays warm enough in tiny pockets could, in principle, produce uncountable flickers of awareness. None of them would have learned anything. All of them would feel as though they had. This is where the extremes start to feel dizzying, even at a slow and gentle pace. Consider the longest timescales physicists have dared to estimate. Numbers so large that the age of the present universe is barely a comma inside them. Across such spans, even the rarest accidents become routine. A working mind, fully formed for a single second, is an extreme rarity. Yet rarity, given endless time, stops being a barrier. It becomes a guarantee. The competing view pushes back hard. Some researchers argue that the universe will not, in fact, last that long in the right way. The expansion of space may thin everything out so completely that no warm pockets remain. Empty space may settle into a state where fluctuations of the needed kind never occur. If that is true, the long parade of accidental minds never happens, and the patient, slow learners remain the only kind of mind there ever was. The extreme case dissolves, and learning by holding is safe. Others suggest that the very rules we use to count minds may be wrong. Counting infinities is a delicate craft. When you try to compare how many real observers there are to how many fluctuation observers there are, the math can give different answers depending on how you slice the problem. This is the measure problem, and it sits unsolved at the center of the puzzle. Until it is solved, the extremes stay extreme, and the question stays open. There is something quietly beautiful in this. The most extreme form of the mystery is not about distance or temperature or speed. It is about whether learning itself is a real feature of the cosmos or a borrowed feeling worn by accidents. The hottest stars and the coldest voids feel ordinary next to that. A neutron star can be measured. A fluctuation mind cannot be questioned, because by the time the question forms, the mind is gone. For tonight, you do not need to decide. You can simply notice that you seem to be holding things. The sound of these words, the shape of the room around you, the slow, soft rhythm of your own breathing. Whether those holdings are the patient work of billions of years, or the briefest flicker in a warm patch of empty space, they feel the same from the inside. That sameness is part of what keeps the puzzle alive. The extremes of this idea do not press in like danger. They open outward like a quiet field at night. Somewhere in that field, the question of whether minds can truly learn or only appear to drifts among the grasses. No one has caught it yet. No one may ever catch it. And still, the wondering itself feels like a kind of holding, gentle and unhurried, carrying you forward into the next slow breath. Consider what it takes to map a world. A surveyor walks the edge of a coastline, marking each bend. Days later, that surveyor returns and walks the same edge again. The bends are where they were. The river still meets the sea at the same soft curve. The map grows because the land waits while we draw it. imagine a mind that cannot wait, a mind that flickers into being holding the picture of a coastline it has never seen, then fades before any second glance is possible. The map would never be checked. The map would never be redrawn. The coastline, if it existed at all, would remain a single private image, lit for an instant and then gone. This is one of the quiet textures of the Boltzmann brain idea. The strange possibility that a single mind could appear in the warm static of deep time, complete with memories of places it never visited. Some physicists treat the thought as a useful puzzle rather than a literal claim. Others wonder whether the math of an old, thinning cosmos really does favor such lonely flickers over full worlds. The question stays open, and inside that openness, the small details start to glow. Think of how science maps the very small. A grain of dust under a microscope shows ridges and pockets, tiny canyons no eye could see without help. A drop of pond water holds a city of moving shapes. None of that detail would survive a mind that lasted only a single instant. The microscope itself would be a memory. The ridges would be a memory. The patient hand that turned the focus knob would be a memory. A brain without a real past could hold the picture, but not the practice. The same is true for the very large. Astronomers map the sky by returning to it. They photograph a patch of darkness on one night, then again months later, and watch for the soft shift of a distant world against the background stars. The shift is tiny. It is the width of a hair held at arm's length, sometimes less. Only the second look reveals it. A mind that cannot keep yesterday cannot catch that motion. The planet, if it is there, simply hides in plain sight. There are textures in the cosmos that exist almost entirely in the gap between observations. The slow pulse of a variable star, brightening and dimming over weeks. The faint wobble of a sun being tugged by an unseen companion. The drift of a comet's tail as it curves around our local star. Each of these is a pattern stitched from many glances. None of them can be seen in one frame. They live in the holding. Some researchers point to this as a gentle argument against taking the Boltzmann brain seriously. The physicist Sean Carroll has suggested that any worldview which says most minds are short-lived flickers ends up undermining itself. If your memories are random noise, then so is your reasoning, including the reasoning that led you to the idea in the first place. The thought eats its own tail. Others are not so sure the argument fully closes the door. They wonder if the measure problem, the deep trouble of counting possibilities in an endless cosmos, might still leave room for the paradox to whisper. The matter remains unsettled. What is certain is that the small wonders of science depend on a world that holds still long enough to be looked at twice. The faint rings around a distant ice giant. The slow shrinkage of a sunspot over a single afternoon. The way frost grows along the rim of a crater as the long lunar night creeps in. These are not facts that arrive all at once. They are textures slowly drawn. Picture an observatory on a mountain ridge, its dome a pale shell against the dark. Inside, a telescope tracks one patch of sky for hours, gathering thin light from something very far away. The image builds grain by grain, the way a soft drawing builds under a careful pencil. If the universe were only a momentary flash in a warm sea of particles, none of that patient building could happen. The drawing would never finish. There would be no pencil and no hand. Maybe that patience is itself a kind of evidence. Maybe the simple fact that telescopes work, that maps stay true from one night to the next, hints that the world is more than a single flicker. Or maybe it only hints that any flicker which contains us would naturally contain the feeling of such patience, woven in like thread. The puzzle does not resolve. It only deepens quietly in the small details. And so the worlds keep refusing to be mapped in any single glance. They ask for another look. They ask for time. The story of how this strange idea entered the human mind begins not with telescopes or starships, but with steam. In the late 1800s, a quiet Austrian physicist named Ludwig Boltzmann sat with a puzzle that would not let him rest. He wanted to understand why heat flows the way it does, why a warm cup of tea cools in a cold room, why smoke spreads through the air and never gathers back into the candle. He was trying to explain the soft, one-way arrow of time using only the tiny dance of atoms. Boltzmann worked in a world without computers, without space probes, without any of the tools we lean on now. He had pencils, paper, and a mind that could hold whole oceans of moving particles at once. From this work came what we now call the H-theorem, a careful attempt to show how disorder grows over time. Disorder, in this sense, is just the spreading out of energy and matter into more even, more mixed states. A neat room becomes a messy room far more easily than the reverse. And on the scale of atoms, the same logic seems to hold. But Boltzmann noticed something troubling in his own equations. If the universe is truly governed by chance at the smallest level, then any arrangement of matter, no matter how strange, has some tiny probability of forming on its own. Given enough time, the random jitter of particles could, in principle, assemble almost anything. A swirl of gas might briefly gather into a planet. A cloud of dust might briefly form a flower, and far more rarely, a small patch of matter might briefly form a thinking mind. This was the seed. Boltzmann himself wondered, in a soft and speculative way, whether the ordered universe we see might be one such fluctuation, a rare lull in an otherwise smooth and featureless cosmos. He did not push the idea hard. He offered it as a passing thought, a strange consequence of treating time as a statistical river rather than a fixed track. For decades, the notion sat quietly in the corners of physics, half remembered, half ignored. The trouble was that Boltzmann's own framing seemed to lead somewhere uncomfortable. If random fluctuations can produce ordered patches, then small ordered patches should be far more common than large ones. A single thinking brain, floating briefly in the dark, with a head full of invented memories, requires far less unlikely arrangement than an entire galaxy or an entire visible universe. The math of probability tilts gently but firmly toward the small. By the middle of the 20th century, as cosmologists began to take the long lifespan of the universe seriously, the old puzzle came back into the light. Physicists working on the very early cosmos, on inflation, on the strange behavior of empty space, found themselves bumping into Boltzmann's quiet ghost again. The question sharpened. If space goes on forever, or lasts for an unimaginably long time, then somewhere, somewhen, these lonely brain-like fluctuations must form. The only real question is how often, and compared to what. In recent decades, the idea has been turned over by careful thinkers in many places. One line of argument, often associated with the physicist Sean Carroll, suggests that any theory predicting we are most likely to be such fluctuations is, in a sense, self-defeating. If our memories and reasoning are random, we cannot trust the very science that led us to the theory. Carroll calls this cognitive instability, and he uses it as a reason to prefer cosmologies that do not flood the future with these lonely minds. Other researchers push back gently. Some, working at places like the Santa Fe Institute, have reanalyzed the old arguments and asked whether the counting of possible observers was ever done fairly. Perhaps the assumptions hide errors. Perhaps the universe ends or resets or behaves in ways that never give the fluctuations enough time. The debate continues, with no clean victor. What is striking, looking back, is how the discovery unfolded. There was no single moment when a telescope swung skyward and revealed the answer. There was no expedition, no photographic plate, no triumphant announcement. The mystery grew slowly in notebooks and quiet seminar rooms, out of equations meant to describe tea kettles and gas clouds. It crept into cosmology through the back door of statistics, and it remains there still, an idea that no instrument has confirmed, no experiment has settled. The history of its discovery is, in a way, a history of forgetting and remembering, of an old worry surfacing again and again in new disguises. The story keeps vanishing into the background, and then, softly, returning to wonder once more whether any of our stories are real at all. Light is the oldest messenger we know. It travels for billions of years across the cold dark, carrying news of stars long gone, of galaxies whose shapes have already changed by the time their glow reaches us. When we look up, we see a kind of museum, a record of things that were. Now imagine that the seeing means nothing, because the seer has no past. The light still arrives. The eye still gathers it. But the recognition, the the long thread that connects this glow to last night's glow simply does not exist. This is one of the stranger corners of the Boltzmann brain idea, a brain born from random thermal motion, drifting in the deep future of an empty cosmos, might form with the impression of having just looked at a star. It might carry the faint sense of color, the feeling of cold air on the skin, the soft conviction that the sky has always been there. But none of those impressions need a sky to exist. They only need the brain to exist, briefly, in the right pattern. What does light mean to a witness with no continuity? Some thinkers say the answer is nothing at all. Light, in our ordinary lives, is meaningful because we compare it. We compare today's sunrise to yesterday's. We compare the red of a dying star to the blue of a young one. Meaning comes from the linking. A momentary mind, formed and dissolved in a single flicker, would have no linking to do. The light, if there even were any real light, would be a sensation without a story. Others wonder if meaning can live inside a single moment. A flash of awareness might already contain its own small world. The brain might feel that it has seen, even if it has not. The brain might feel that it understands, even if there is nothing to understand. This is one of the gentler surprises of the thought experiment. It suggests that meaning, for us, may be less about the outside world and more about the inner pattern, the pattern of remembering, the pattern of expecting, the pattern of being a self that persists. Here is something most people do not expect. In our actual universe, light is almost always older than the eye that sees it. The sunlight warming a field at noon left the surface of the sun about 8 minutes earlier. The starlight on a clear night left its star years, centuries, sometimes thousands of years ago. Every act of seeing is, in a small way, an act of remembering on the universe's behalf. The cosmos stores its own past in the photons drifting between things. And memory, in this view, is not only something inside a skull, it is something woven into the light itself. A Boltzmann brain would not have access to that woven history. Even if photons happen to strike it, the brain would not know where they came from. It would not know that the soft red came from a cooling ember of hydrogen fusion, or that the pale blue came from a young, hot giant. It might invent stories about the light. It might feel certain those stories were true, but the certainty would be a feature of the pattern, not a connection to anything real. Some researchers find this unsettling because our own certainty about light feels so solid. We trust that the sun we see is the sun that was there. We trust that the stars in tonight's sky are the same stars we saw last week. The trust is not proven. It is assumed gently every moment by a mind that keeps stitching one image to the next. Sean Carroll and others have argued that without this stitching, science itself becomes impossible. If we cannot trust our memories of yesterday's measurements, we cannot trust today's conclusions. A competing view says the trust is built in, almost mechanically. The brain evolved in a world where memories usually matched reality, because creatures whose memories did not match reality did not survive. Under this view, our confidence in light is the residue of long, slow shaping by the world itself. But this view assumes the long, slow shaping really happened. A momentary brain would carry the same confidence with no shaping behind it at all. So we are left with a quiet surprise. Light, for us, may not be a simple thing arriving from outside. It may be a partnership between the photon and the remembering mind. Take away the remembering, and the light becomes something else, something we have no good word for. Not darkness, not blindness, just a glow that nothing holds onto. The question of which kind of seer we truly are remains open, drifting softly above us like the starlight itself. Recognition is one of the quietest miracles the mind performs. You see a face across a room, and before you can think, you know it. You hear 3 notes of an old song, and the whole song unfolds in your chest. You step into a kitchen you have not visited in 20 years, and your hand reaches for the light switch without being told. None of this feels like work. It feels like the world greeting you back. Yet recognition is not a single thing. It is a slow web of connections, woven between the mind and everything outside it. The light that bounces off a familiar face must match a pattern stored somewhere inside you. The smell of pine must find the older pine it once met. For recognition to happen at all, the inside and the outside must agree on a shared past. Two histories must touch. This is where the puzzle of the lonely brain grows strange. If a mind formed in deep space for only a single moment, it would still feel recognition. It would feel the warmth of an old friend. It would feel the familiar shape of its own bedroom. None of those things would actually exist outside the mind. The recognition would be perfect. The match would be unreal. So the question opens: how can we tell true recognition from invented recognition? The honest answer is that from the inside, we may not be able to. The feeling is the same either way. One possibility is that recognition is always partly a private trick, a comfort the brain builds for itself, whether or not the world cooperates. Another possibility is that recognition only works because the world really is steady, really has held still long enough for our patterns to take root. Most thinkers favor the second view. The first view simply cannot be ruled out. The strangeness deepens when you notice how recognition links systems that should not be linked. A star you saw as a child still shines tonight, and your mind reaches across all those years and binds the two glances together. The light has traveled. The eye has aged. The neurons have shifted and rebuilt themselves many times. Yet something inside you says, that one, the same one. Whether anything in the physical world truly carries that sameness across so many changes is an open question. The star does not know you. The light does not remember its source. Only the mind insists on the thread. Recognition also seems to leak between scales. We recognize our own breath, the rhythm of our own footsteps, the curve of a coastline on a map. We recognize seasons we have not lived through in years, the smell of certain rain, the slant of late autumn light. We recognize entire ideas, the shape of a math problem, the feel of a story turning toward its end. Each act of recognition stitches a small piece of the universe to a small piece of us. Pull the thread, and a great deal unravels. Some researchers wonder whether recognition is the deepest evidence we have that our memories belong to a real history. The argument runs like this: a lonely fluctuation brain would carry recognitions, but those recognitions would not keep matching the world. The kitchen would not actually contain the light switch. The friend would not actually arrive. In a real universe, recognition is rewarded again and again. The pattern inside finds its echo outside. That ongoing agreement, repeated across a lifetime, may be the closest thing we have to prove that the past was not invented just now. A competing view points out that even this agreement could be part of the illusion. A momentary mind could include the feeling of confirmation, the sense that the world keeps cooperating without any world being there at all. The trap is tight. Every test we might run uses the very faculties under question. The eyes that check, the memory that compares, the reasoning that judges, all are inside the brain doing the wondering. For now, the puzzle stays open. Most scientists treat the lonely brain idea as a useful warning rather than a likely truth, because taking it seriously would dissolve every connection we trust. Recognition would become a private dream. The web of links between minds and stars and seasons would be a kind of solitary music played in an empty hall. Still, the music is beautiful. The light switch is where your hand expects it. The old song unfolds. The familiar star burns in its familiar place. Whether these matches are real exchanges or quiet inventions, the harmony itself remains. Something is playing. Something is being recognized. The question of who or what listens is still drifting somewhere out beyond the reach of our certain knowing. Picture a city built in a single night. Towers rise from empty ground. Streets fill with the sound of footsteps. Lights bloom in countless windows. By morning, the city has crumbled back into dust, and no one remembers it stood. This is one way to imagine the Boltzmann brain thought experiment at the largest scale. Whole structures of thought, whole cities of self, flickering up out of the quiet and sinking back down before any record can form. The universe we live in seems to change slowly. Stars take millions of years to gather and burn. Galaxies turn like enormous wheels, each rotation lasting hundreds of millions of years. Mountains rise and erode across spans we can barely picture. We tell ourselves that change is patient, that the cosmos moves on a clock so slow it feels still. Yet the brain hypothesis asks us to consider a different kind of change, one that happens in an instant and leaves no trace behind. In the deep future imagined by some physicists, the universe may grow so empty and so cold that ordinary stars no longer exist. Galaxies drift apart. Atoms themselves may slowly come undone. In that long silence, the only events left would be tiny random shudders in the leftover fields of energy. Most of those shudders would do nothing at all. A few might gather by pure chance into something more, a patch of dust, a grain of matter, and far more rarely a thinking thing. If such a thing did form, it would last only for a moment. The same randomness that built it would soon pull it apart. Its city of thought would crumble back into the cold. No memory of it would survive, because there would be no one and nothing left to remember. The change would be total, and it would leave no echo. Some theorists argue that, given enough time, this kind of fleeting formation might happen more often than full universes ever do. That claim is far from settled. One view holds that the numbers simply favor the small, brief event over the large, lasting one. A whole cosmos is a very particular arrangement, while a single thinking pattern is a much smaller order to fill. By that math, brief minds in the dark could outnumber long-lived ones like us. A competing view argues that the universe may never reach such a quiet state at all. It may end in some other way, or it may renew itself, or it may follow rules we have not yet found that forbid these stray formations. The change that matters most here is not in stars or galaxies. It is in the very idea of what counts as a moment. We are used to moments that connect. 1 second leads into the next. A thought finishes itself. A day builds toward an evening. The brain hypothesis imagines moments that do not connect at all. A flicker of awareness, complete in itself, with no before and no after. The change is instant and total, like a candle lit and snuffed in the same breath. Right now, in our own time, the universe is still changing in ways we can almost see. It is expanding, and that expansion seems to be speeding up. Distant galaxies are drifting farther from us each year. billion years from now will look thinner than the one above us tonight. A trillion years from now, observers in any one galaxy may see no other galaxies at all. The slow forgetting of the cosmos has already begun, in a sense, as light from far places fades beyond reach. Whether that long fading ever leads to the strange flicker of a lone mind in the dark, no one can say. Some researchers find the idea useful as a way to test our theories. If a theory predicts that brief minds should vastly outnumber long-lived ones, they argue something in the theory must be off. Others see the whole picture as a sign that we need new ideas about time, about probability, about what it means for something to exist at all. The mystery sits in this gap. We see change all around us, patient and grand. We also imagine change so quick it leaves no mark. Both kinds may be real. Only one of them lets stories be told. The other builds cities by midnight and forgets them by dawn, over and over, in a darkness we cannot visit. Tonight, as you rest, the slow change continues, the kind that lets one breath follow the next, the kind that lets a thought finish itself. Whether any other kind of change is happening somewhere far away, in some far time, remains an open and quiet question. Light has always been the way we know ourselves. The first soft glow of morning across a wall, the warm color of a lamp in a quiet room, the cool blue spill of evening through a window. We learn who we are partly by the way light falls on the things around us and on us. So tonight, as the question of identity drifts forward, it helps to think about light and about what it would mean if our sense of self were only the briefest flicker in the dark. Imagine the deep field of space. Out there, in the cold between galaxies, almost nothing happens for unimaginable stretches of time. Now and then, by pure chance, particles arrange themselves into a brief pattern, the way frost sometimes forms a strange shape on a window. The boltsman brain idea wonders if a thinking mind could appear in just this way, lit from within by a single moment of awareness, then gone. If that mind glimpsed light, the light would not really be sunlight. It would be the memory of sunlight painted inside the flicker. There is something gentle in picturing this, a small glow alone in the dark, believing it is reading by a lamp, believing the soft amber color is warming the page. The question is whether we can tell the difference from inside. The light that seems to enter your eyes right now feels continuous, layered, full of history. It seems to come from a sun that rose this morning and will rise again. But a momentary mind would feel exactly the same thing. Its inner light would be vivid, even though the outer light never happened. Some thinkers, including the physicist Sean Carroll, have argued that this is a reason to doubt the whole picture. If we were such a flicker, our memories of physics, of telescopes, of the bright rings of Saturn, would all be untrustworthy. The light we think we measured would be imaginary. And a theory that says our observations are imaginary cannot really support itself. So perhaps the universe must be arranged in a way that makes ordinary observers, with real light entering real eyes, far more common than lonely flickers. That is one view. It is not settled. Other researchers wonder if the math is not so simple. The question depends on how you count possible observers across an unimaginable stretch of cosmic time, and on what the late universe actually does as it cools. Recent work, including reanalyses from groups like the Santa Fe Institute, has suggested that in some models, the rate of these random minds may be far lower than older estimates feared. In other models, it remains stubbornly high. The light, in a sense, has not yet been measured. The question stays open. Picture the colors that fill our sky. The pale rose of a nebula seen through a long exposure. The deep teal of an ice moon catching distant sun. The soft, scattered blue of an atmosphere holding the day. Each of these colors carries a story. The rose tells of hydrogen, glowing as it gathers into new stars. The teal whispers of frozen water and methane. The blue speaks of air, of a small rocky world, of a long, quiet evolution. If memories never happened, the colors would still arrive, but their stories would not. A flicker mind would see rose without knowing hydrogen. It would see blue without knowing air. And yet, something tender remains. Even a single moment of seeing light is, in its own way, complete. A flicker that believes it is watching the dawn is still watching something. The pattern of color it experiences is real to it, even if the dawn is not. This is part of why the thought experiment is taken seriously rather than dismissed. It asks what the minimum ingredient for an experience of light might be, and whether that ingredient could occur without the long chain of cause and effect we assume sits behind it. The competing intuition is just as strong. Light, in the universe we seem to live in, is wildly consistent. The same spectral lines appear in distant galaxies as in lamps on Earth. The cosmic background glow has been mapped in extraordinary detail. These patterns feel too rich, too cross-checked to be the invention of a brief thermal accident. Many physicists take that richness as quiet evidence that our observations are anchored in something real. Others answer that a sufficiently improbable flicker could, in principle, contain any pattern at all, including rich ones. The argument keeps folding back on itself. So tonight, watch the imagined light in your mind. The warm lamp, the cool window, the far stars. Let it be beautiful without needing to be proven. Whether the light is ancient or only a moment old, the wondering itself is soft, and the dark around it is very, very wide. Sound, in the way we usually mean it, cannot travel through empty space. There is no air between the stars to carry a vibration from one place to another. And yet, the cosmos is not silent. Instruments in orbit have caught the low hum of the solar wind. The slow throb of plasma waves around planets. The soft crackle of charged particles spilling past spacecraft. When scientists shift these signals into the range our ears can hear, the universe begins to sing. It moans. It whispers. It clicks and hisses like a long, slow tide. There is a recording made by a probe drifting near a giant planet that sounds almost like wind moving through a vast cathedral. There is another from a spacecraft crossing the edge of the sun's reach that resembles a chorus of distant voices. None of these are sounds in the way a footstep is a sound. They are vibrations translated. They are patterns of energy reshaped into something a human ear can recognize. Now imagine gently that one of these signals reaches a mind that has only just formed. A Boltzmann brain, if such a thing exists, would be a fleeting pocket of order in a cold and quiet sea. It would arrive already thinking. It would arrive already remembering. And inside that remembering might be the sound of wind through trees, or the murmur of a kitchen at evening, or the soft static of a radio left on in another room. None of these sounds would ever have happened. They would be dreams with nowhere to land. This is one of the strangest features of the thought experiment. A mind built from chance would still hum with the sense of being heard. It would carry the echo of voices it never met. It might even believe it had once listened to whale song through a ship's hull, or heard the rumble of a glacier breaking somewhere far north. The memory of sound is, in some ways, the most intimate kind of memory. It feels close. It feels like company. And yet, a momentary brain would carry these auditory ghosts without any source for them. Some thinkers find this image troubling. Others find it useful. One view holds that if our memories of sound are unreliable evidence for a real past, then so is every other memory, and the whole structure of knowledge begins to wobble. This is the cognitive instability worry. The idea that a universe full of brief minds undermines its own reasoning. A competing view suggests that this very wobble is the point. If a theory predicts that most thinkers are illusions, the theory may simply be wrong, and the wobble is a signal pointing us toward better physics. The cosmos does seem to favor real sound, in a sense. Pressure waves move through the gas between galaxies. Sound waves once rippled through the hot plasma of the early universe, leaving faint patterns that astronomers can still measure in the arrangement of galaxies today. These ancient ripples are sometimes called the oldest music we have. They are real. They have a source. They carry information across billions of years. A lone fluctuation brain, by contrast, would carry no such inheritance. Its inner sounds would not trace back to any drum, any throat, any colliding wave front. They would be patterns without parents. And here the mystery deepens, because from the inside, a remembered sound and a real sound feel identical. The brain cannot tell the difference. The ear has nothing to compare against except other memories, which themselves might be invented. Researchers who study this paradox are careful to say what they do not know. They do not know how often, if ever, such brains arise. They do not know whether the universe will last long enough or grow empty enough for the conditions to allow them. They do not know whether inflation, the very early expansion that may have shaped everything, opens or closes the door to such possibilities. Each model gives a different answer, and the answers disagree by enormous amounts. For tonight, it is enough to listen. The real universe does make sound in its own quiet way. The hiss of solar wind, the chime of magnetic fields, the long sigh of plasma at the edge of a star's reach. These vibrations are recorded, studied, shared. They are evidence that something is out there, vibrating, sending its patterns outward. Whether the sounds inside your own mind tonight come from a life truly lived, or from a brief flicker of order in a darker, deeper sea, is a question no instrument has yet answered. The hum continues either way. The cosmos keeps singing softly, and the mind keeps listening, and the source of the music remains, for now, beautifully unresolved. There is a quiet kind of mathematics that the sky has always followed. The planets move in ellipses, sweeping equal areas in equal times. The moon pulls the sea up and down by an amount that can be written on the back of a small card. A comet returns on a schedule older than any written language. If you know the numbers, you can point to a place in the night and say a faint object will be there, and it will be there. The cosmos keeps its appointments. Tonight, the question is what those appointments would mean if no mind could carry them across time. Imagine a sky that obeys every law perfectly, yet has no observer who remembers seeing it before. The math would still be true. The orbits would still close. Only the recognition would be gone. The numbers behind orbits are surprisingly gentle. Kepler noticed that the square of a planet's year, divided by the cube of its distance from the sun, gives the same small ratio for every world in our system. Mercury, Earth, Saturn, Neptune, all of them obey the same quiet rule. Newton later showed why, with a single equation about how mass pulls on mass. One short line of symbols, and the clockwork of the solar system falls open. A mind that could not remember yesterday could still, in principle, derive this in an afternoon and watch it confirmed by morning. But the confirmation would not feel like confirmation. It would feel like a first encounter every time. Some of the most beautiful numbers in nature show up again and again, as if the universe were humming the same chord in different keys. The ratio of a circle's circumference to its diameter appears in waves, in orbits, in the spread of heat across a cooling star. The golden ratio shows up in the spiral arms of certain galaxies and in the curl of a nautilus shell back on Earth. The speed of light, written as a simple constant, sets the size of every atom and the reach of every signal we can send. These constants do not change. They are the same in the morning and the same in the deep middle of the night. A Boltzmann brain, if such a thing could exist, would face a strange relationship with these numbers. It might be born already knowing them, the way you might wake from a dream still holding a melody. The constants would feel like memories, even if no learning had ever happened. This is part of what makes the thought experiment so slippery. The math of the universe is so consistent that a fleeting mind formed by chance could carry the appearance of a long education without ever having lived a long life. The distances are harder. Light from the nearest star beyond our sun takes a little over 4 years to reach us. Light from the center of our galaxy takes about 26,000 years. Light from the most distant galaxies we can see has been traveling for more than 13 billion years. These are not numbers a mind invents. They are measured by patient comparison, by parallax angles, by the dimming of certain standard candles, whose brightness astronomers have worked out across generations. A single fluctuation could not perform that work. It could only inherit the answer already written, with no path leading back to how it was found. This is one reason some thinkers find the Boltzmann brain idea unstable on its own terms. If you trust the math you remember, you also have to trust the long process that produced it. The numbers come with a history attached. Pull the history out, and the numbers begin to float, unmoored. One view holds that this gentle contradiction is the answer itself, a sign that real observers must be embedded in real causal chains. Another view says the contradiction only deepens the puzzle, because a fluctuation could be tuned to include the appearance of trust as well. Which side is right is not yet settled. Still, the math sits there, calm and waiting. The orbital period of the Earth, 365.25 days. The tilt of its axis, about 23.5 degrees. The gravitational constant, a tiny number that nonetheless governs every falling apple and every collapsing star. These quantities are simple enough to print in a small notebook. They are also enough to predict eclipses centuries in advance. A sky that becomes a stranger each night would still obey them. The strangeness would not be in the math. The strangeness would be in the watching, in whether anything carries the pattern forward from one evening to the next. The universe keeps its appointments. The open question is whether anyone is truly there to keep them with it. Think for a moment about what holds a life together. Not the bones, not the breath, but the thin line that runs through every moment and ties them into a single story. That line is time, or rather, our sense of it. And our sense of time depends on memory. Without memory, time would still pass, but it would not feel like passage. It would feel like a single endless now, with nothing before it and nothing reaching toward what comes next. This is the fragile balance the Boltzmann brain idea asks us to consider. A thinking mind needs more than thought. It needs the soft thread that links one thought to the one before it. Pull that thread out, and the mind becomes a flash, a moment of awareness with no map of where it sits in the great unfolding of things. Physicists who study this puzzle often point out how delicately the conditions for a long, ordered life are arranged. Our universe began, as far as we can tell, in a state of very low entropy. Entropy is just a word for disorder, for the mixing and spreading of energy. The early cosmos was smooth and hot and strangely tidy. From that quiet beginning, everything else became possible. Stars could form, planets could cool, chemistry could settle into the patterns we call life. Time itself, in the way we experience it, seems to flow from that early low entropy state toward the warmer, more shuffled future. Change that starting condition by even a little, and the picture falls apart. If the early universe had begun more disordered, there would be no clear direction for time to point. Galaxies might never have gathered. Suns might never have lit. And the slow chains of cause and effect that let a memory form in a living brain might never have taken hold. This is why the Boltzmann brain question is unsettling in such a quiet way. It does not threaten the universe. It threatens our confidence that the universe we remember is the one we are actually inside. One view, held by many cosmologists, is that the low entropy beginning is real, that our memories trace back through real moments, and that the thread of time we feel is genuine. Another view, the one the paradox forces us to take seriously, is that a single fluctuated mind in a warm and faraway future would feel exactly the same from the inside. It would have a sense of past. It would have a sense of tomorrow. And it would be wrong about both. Our planet, hanging in its narrow zone around a steady star, depends on a long list of fragile balances. The right distance from the sun, the right thickness of atmosphere, a magnetic field that turns aside the worst of the solar wind, a moon large enough to steady the tilt of our axis, water that stays liquid across most of the surface. Each of these is a thin condition, and together they let memory exist at all, because they let creatures exist who can carry memory in soft, electrical patterns inside their skulls. The Boltzmann brain idea is, in a way, the same fragility seen from the other side. It asks what happens when you strip away every one of those conditions and keep only the bare minimum needed for a moment of thought. No planet, no star, no atmosphere, just a random arrangement of particles briefly cohering into something that thinks it is alive. The thinness of that scenario is almost unbearable. And yet the mathematics in certain models allows it. Most working cosmologists treat the paradox not as a literal description of our condition, but as a warning sign. If a theory predicts that lonely fluctuated minds should be far more common than embodied beings on real worlds, the theory is probably missing something. The thread of time we feel running through our days is treated as evidence, not illusion. The fact that our memories agree with one another, that the rocks and the light and the fossils all tell the same story, is taken as a sign that the long version is the true one. Still, the question lingers in the quiet hours. How delicate is the system that produced you? How many small constants had to settle into their narrow windows for a single remembered afternoon to be possible? The thread of time is thin. It might be woven into the deep structure of the cosmos, stretching back through real billions of years. Or it might be shorter than we think, a brief shimmer of order in a much vaster warmth. We do not yet know which picture is right. For now, the thread holds, and the night around you is still. Beneath every question we have asked, tonight lies a deeper one we have not asked plainly. What is consciousness? And why does it feel like anything at all to be a small, warm mind nested inside a vast, cold cosmos? Without an answer to that, the puzzle of the Boltzmann brain cannot fully close. We are trying to weigh the likelihood of a thinking moment against the likelihood of a thinking universe, and we do not yet know what a thinking moment truly is. Some researchers wonder if consciousness is something the brain produces, the way a fire produces heat. In this view, the right pattern of matter, arranged in the right way, simply gives rise to inner experience. If that is true, then a thermal fluctuation that briefly forms the same pattern would also briefly feel like something. The Boltzmann brain becomes possible because awareness is portable, requiring only the correct arrangement, no matter how it came to be arranged. Others find that idea incomplete. They wonder if awareness depends on history, on the long chain of cause and effect that shaped a particular brain. By this thinking, a freshly fluctuated structure with no real past might not be conscious at all, even if its wiring perfectly matched a brain that is. The pattern alone would not be enough. The story behind the pattern would matter. If this view is right, then most Boltzmann brains would be hollow, and the paradox softens considerably. A third line of thought goes further still. Some thinkers suspect that consciousness is more fundamental than matter, woven into the basic fabric of the world. In this picture, often called panpsychism in its gentlest form, tiny seeds of experience exist everywhere, and brains gather them into the rich inner life we know. If that is true, the question of a lone fluctuating mind in deep strange new shape. There would be no clear line between a real brain, a flickering one, and the quiet stirrings of matter itself. None of these ideas has been confirmed. Each has thoughtful defenders and thoughtful critics. The deep difficulty is that we cannot measure inner experience directly. We can scan a brain. We can record its rhythms. We cannot reach inside and feel what it feels. This is sometimes called the hard problem of consciousness, the gap between the physical activity we can observe and the warm presence of being someone, somewhere, right now. Because that gap is still open, the Boltzmann brain question cannot be settled by physics alone. It leans on assumptions about minds that physics has not yet earned the right to make. If a fluctuated pattern is conscious, the paradox bites hard. If only a pattern with a real causal past is conscious, the paradox loosens. If consciousness is something subtler still, we may need a whole new language before we can even ask the question properly. There are quieter mysteries tucked beside this one. We do not know why subjective experience seems unified, why the many separate signals in a brain feel like one single moment of seeing and hearing and thinking together. We do not know why time feels as it does from the inside, flowing forward with a soft pressure. When the equations of physics treat past and future almost the same. We do not know whether memory is essential to selfhood, or whether a mind with no past could still feel like a self at all. These open questions are not failures. They are the working edge of a field that is only beginning. Just a few generations ago, the brain was a near total mystery. Now we can watch single neurons light up as a thought forms. We have learned a great deal, and yet the deepest layer of the puzzle still rests in shadow. That shadow is where the Boltzmann brain idea lives, half physics, half philosophy, waiting for tools that have not been invented yet. Some researchers believe progress will come from better theories of information, from understanding how patterns carry meaning. Others suspect the answer will come from physics, perhaps from a clearer picture of time, or of how the universe holds together at its smallest scales. Others think the breakthrough will be conceptual, a new way of framing the question that makes the old confusion melt away. We do not know which path, if any, will lead through. For tonight, it is enough to rest in the strangeness. A mind is wondering about minds. A pattern of matter is asking whether patterns of matter can wonder. The answer is not in. The silence around the question is not empty. It is full of careful work, slow thinking, and the patient hope that someday we will understand a little more of what it means to be aware at all. Let us drift forward in time now, gently, the way clouds drift across a still lake. Picture the cosmos 1,000,000 years from tonight. The constellations we know will have shifted, slow as a sleeping breath, into shapes no eye has ever traced. The bright star that anchors the north will have drifted from its post. The familiar patterns we learned as children will have softened into new arrangements. And somewhere in all that quiet movement, the question we are wondering about tonight will still be open. In 1,000,000 years, brains very much like ours may still be looking up, or they may not. The question of whether a mind needs a long, real history to be a mind at all may still hang in the air. Some thinkers suggest that as long as matter cools, as long as particles drift through empty space, the chance of a stray fluctuation forming a thinking pattern never truly reaches zero. Others argue the opposite, that the conditions for such a fluctuation are so rare they may never arise in any meaningful sense. The disagreement is gentle, but it is real, and it has not been settled. Move further forward. 1,000,000,000 years from now, our sun will have grown warmer and brighter. The slow swelling of its outer layers will have made the inner planets uncomfortable, then unrecognizable. Oceans will have boiled away into thin air. The familiar blue marble we live on will be a different world, perhaps a rocky one, perhaps a misted one, perhaps something we have no word for yet. Whether anyone is left to remember what it once looked like is itself part of the mystery. Stars will still be born during this time. In the slow swirls of cold gas between galaxies, new suns will ignite. Some will be small and red, burning patiently for trillions of years. Others will flare and fade quickly. The cosmos will keep making fresh light long after our particular star has finished its work. And around some of these new stars, new worlds may gather, new oceans may form, new minds may someday wonder the same question we are wondering tonight. The continents of Earth, too, will keep drifting. They have moved before, joining into single great landmasses, and then breaking apart again. In the deep future, they may join once more, forming a single quiet continent surrounded by one wide sea. The mountains we know will erode into soft hills. New mountains will rise where there is now flat ground. The map will be redrawn slowly, without anyone watching. Then comes a stranger stretch of time. Trillions of years from now, the small red stars that burn most patiently will begin to wink out. Galaxies will drift further apart, carried by the quiet expansion of space itself. The night sky, if anyone is still looking, will hold fewer and fewer companions. Eventually, some models suggest the universe will become a very thin, very cold place. A great quiet. A long evening with almost nothing in it. It is in this far, cold future that the original puzzle becomes most interesting. If the universe lasts long enough, and if random fluctuations can still occur in its thin warmth, then perhaps brief patterns of order keep appearing. A swirl of particles that almost resembles a thought. A flicker of structure that almost resembles a memory. Some physicists wonder whether, given enough time, such flickers might outnumber every mind that ever lived in the warmer, busier ages of the cosmos. Others doubt this picture entirely. They suggest the universe may end, or change, or behave in ways that prevent such lonely fluctuations from ever forming. The math does not yet agree with itself. What does it mean for a cosmos to keep becoming new things when there may be no witness left to notice? This is not a sad question, only an open one. Some thinkers find comfort in the idea that the universe does not need witnesses to be beautiful. Others feel that beauty and witness are somehow tangled together, that a sky unseen is a different kind of sky. Neither side can prove the other wrong, not yet. So we sit for a moment with this gentle forward look. The sun will swell. The continents will drift. Old stars will fade, and new stars will catch fire. Patterns will form and dissolve in the dark, and somewhere along that long, slow path, the question of whether a mind can exist without a true past, whether memory needs history, whether witnesses are necessary at all, will still be drifting too, unanswered, unhurried, waiting for someone, perhaps, to wonder about it again. Step back now, as far as your mind will let you drift. Pull away from your body, from the room, from the quiet hum of the evening. Rise above the city, above the clouds, above the thin blue shell of air that wraps the earth. Keep rising past the moon, past the planets, past the sun, until our whole solar system becomes a single bright mote in a great slow river of stars. Keep going until the galaxy itself becomes a faint spiral, one among uncountable others, scattered through a darkness so wide that even light grows tired crossing it. From this distance, the question of memory begins to look different. It softens. It loses its edges. The worry of whether your recollections are real, whether your past truly happened, whether you are a brief flicker of warm thought in a cold and ancient void. All of it becomes smaller, quieter, more wondrous than worrying. Because from out here, the strangest thing is not the puzzle. The strangest thing is that there is anyone, anywhere, asking it. The atoms in your hands were forged inside stars that died long before the earth existed. The calcium in your bones came from the cores of giant suns that collapsed and burst, scattering their ashes across the dark. The iron warming your blood was made in the furnace of a supernova. The oxygen filling your lungs right now was breathed out by ancient stars, then drifted for billions of years before settling into the air above this small blue world. You are not separate from the cosmos. You are the cosmos, briefly arranged into a shape that can think and feel and wonder whether any of it is real. That, perhaps, is the heart of the mystery. Not whether your memories are illusions, not whether you are a fleeting fluctuation in some far future sea of warmth. The deeper wonder is that the universe, in all its silence and scale, has somehow folded itself into a small, warm pattern that knows it is here, even if the answer were that nothing outside this moment is real. The moment itself would still be astonishing. A brief shimmer of awareness, lit from inside by curiosity, glowing for a heartbeat against an immense and patient dark. The thought experiment of the Boltzmann brain was never meant to frighten anyone. It was meant to point at something the math seems to whisper, and to ask, gently, what we should make of that whisper. Some thinkers say the math is telling us our theories are incomplete. Others say it is telling us our assumptions about time and probability are wrong. Others still say it is telling us something honest and uncomfortable about how rare a real, structured universe must be. The question remains open. It may stay open for a very long time. It may even outlive the people now asking it. And yet, while it stays open, life continues. Children are born. Bread is baked. Snow falls on quiet streets. Someone somewhere is listening to a soft voice in the dark and feeling sleep begin to settle in their shoulders. Whatever the answer turns out to be, these small, ordinary things are the texture of being here. They are what the cosmos feels like from inside one of its thinking patterns. Perhaps that is the gift of sitting with a mystery this large. It does not give you an answer. It gives you a sense of proportion. It reminds you that you are made of star stuff, that your atoms have traveled farther than any ship ever will, that the warmth in your chest tonight is the warmth of an old, old fire, passed gently from one form to another for billions of years. Whether your past is a long, unbroken thread or a fresh pattern woven into this single instant, the wonder is the same. You are here. The stars are out. The universe somehow is looking at itself through your quiet eyes. The question of whether memory is real, whether the cosmos is real, whether you are a long story or a brief gleam, may never be settled. That is not a failure. That is the shape of the deepest questions. They do not close. They open again and again, like soft doors in an endless house. Each generation walks through them, looks around in awe, and leaves them open for the next. For tonight, that is enough. The mystery does not need to be solved. It only needs to be felt. And as you lie there, breathing slowly, drifting toward sleep, the whole long, strange, beautiful universe is breathing with you, wondering quietly about itself through the soft, small lantern of your mind. We have come a long way together tonight, you and I, through a quiet country of open questions. we sat with the soft edge where memory begins. We wondered what a mind without a past might feel. We let the stars drift overhead without names, and we let the names drift back, and we did not try to decide which version was true. The puzzle at the heart of all this still stands. A physicist named Ludwig Boltzmann gave us the first hint more than a century ago when he asked why the universe started so orderly. From his question, others built a stranger one. In a cosmos that lasts long enough, random jitters of heat could, in principle, gather into something that thinks. A brain in the dark, a flicker of a mind, holding memories of a life it never lived. We do not know if this is our situation. Most thinkers find the idea deeply uncomfortable, and that discomfort itself is a kind of clue. If we were such flickers, our reasoning would have no ground to stand on. So many researchers treat the puzzle as a signal that our theories of the early universe are not yet finished. Others wonder if inflation, the rapid stretching of space in the first instant, somehow tilts the odds back toward real observers like us. The math is unsettled. The measure problem, as it is called, remains open. Sit with that for a moment, but lightly. The point of this long, slow wondering was never to frighten you. It was to show you how thin the line is between what we know and what we only assume. Your memories may be the trace of a long, real life. They almost certainly are. And the very fact that we can ask the other question and feel the strangeness of it is a small marvel in itself. Now let your thoughts soften. Imagine a small blue planet turning in the dark, its oceans catching the light of a quiet moon. Clouds drift across its night side in slow white spirals. A coastline glows faintly where a city sleeps. Somewhere on that coast, a window is open to the breeze, and the curtains move the way curtains have moved for 1,000 years. Pull back gently. The planet becomes a pale dot against the deep. A sun warms one side of it, and the rest is held by stars. The whole system drifts inside a slow turning wheel of light, one arm of a galaxy that takes 200 million years to complete a single turn. We are riding that wheel right now, you and I, at a speed too fast to feel. The ride is smooth. The ride has always been smooth. Pull back further. the galaxy joins others in a quiet local group, and the local group drifts among superclusters, and the superclusters trace long, soft filaments through the dark. From far enough away, the universe looks almost like a web of pale silk, glowing where matter has gathered, dim where the great voids open. It is enormous. It is patient. It does not hurry. And somewhere inside that web is the room where you are resting now. A small, warm pocket of atoms that have learned, for a little while, how to wonder. Whether your memories began this morning, or in childhood, or in some deeper unknown, you are here, and the wondering is real, and that is enough. The mystery stays open. We may understand the Boltzmann puzzle better in the coming decades. New work on entropy, on the early universe, on the measure of possible worlds, may slowly narrow the question, or the question may stay with us for centuries, the way the deepest questions tend to do. We do not need an answer tonight. The answer can wait. Let your breathing slow. Let the stars settle. Let the soft turning of the galaxy carry you the way it has always carried everything in it, gently, without effort, without end. The universe is vast and old and quiet, and it is holding you the same way it holds the moons and the dust and the long, slow rivers of light. Whatever you are welcome here. Whatever your memories are, they brought you to this calm moment. The cosmos does not ask you to solve it before you sleep. It only asks that you rest inside it for a little while, one small, wondering thing among many. Subscribe for a brand new space topic every night. One tap, and something incredible is waiting for you tomorrow. Sweet dreams.